Alright, today we talk about the camera. So before we go detail the camera, we go over a little bit about the autonomous vehicle. We have the five level autonomous vehicles. In each level, there are different conditions, right? For example, the full autonomous, the vehicle is capable of the performance or driving function under all conditions. The driver might have the option to control the vehicle, right? So in the market, they have the model already on the market right now, Uber, Waymo, and Tesla. So we briefly introduction about that kind of car. The first Uber. Uber, they use the Volvo CS90, right? Right here, the Uber technology. Autonomous vehicle right here, they apply the camera right here to have focus on both close and far field, watching the braking vehicle, closing pedestrian, traffic light, classify, and signal. Right, LiDAR to see three dimensions, scan environment. And also they have side and rear facing camera work in collaboration to construct continuous view of the vehicle surrounding. Right here they have GPS and wireless data capability. Right here they have 360 radar car right on the front rear right here. And right here that's the processing the real-time data. And the integrate cooling solution keep the component running optimally. Okay. And generally, the self-driving Uber they use the 7 cameras, one laser, one initial measurement unit, and then so compute the data storage 360 radar cover it, right? So general they use the camera, okay, they use the radar, and they use the LiDAR. And the function this one I already taught last video, so if you have time, you go back to see the video how the LiDAR, radar, and camera works. Another car in the market is Tesla Autopilot. The image right here show you the all camera, left, right, rear camera. Right here to detect, recognize, and object. All right. So you can see that right here. You can front the narrow forward camera, maximum distance to 50, main forward camera 150, wide forward camera, and rearward looking side camera. All the Tesla cars they covered by camera. Okay, and not only that, they combine with the radar in maximum distance 160 meters and ultrasonic maximum distance 8 meters. So in the Tesla car, they really focus on the camera, and the forward-facing optical area consists of 4 cameras with differing focal lengths. So the narrow forward camera captures footage up until 250 meters in front, and forward camera with a slight larger opening angle looks up until 150 meters in front, and wide angle camera that captures 60 meters in front. A set of forward-looking side camera that capture footage 80 meters in front. Okay, and the radar, so look forward radar can see up to 160 meters ahead of the car. And not only that, they use sonar or 360 ultrasonic sonar detect obstacle in the 8 meter radius around the car. Okay, so the Tesla not using the LiDAR sensor despite its plan to offer level 4 and even level 5 autonomous driving with this setup. So unlike many other manufacturers like Uber and Waymo, Tesla convinced to set up a high-performance cameras, a couple with a powerful radar sensor will be sufficient for level 4 and 5 autonomy. So what are the criteria for selection sensor? First thing, range. LiDAR and radar system can detect object distance ranging from few meter to more than 200 meter, 200 meter, right? And spatial resolution, LiDAR can have the spatial resolution in order to of the 0.1 degree. Okay, and radar, on the other hand, cannot resolve small feature very well, especially as the distance increase. So spatial resolution camera system is defined by the optic, by the pixel or size on the image, and by its signal to the noise ratio. Robustness in the darkness. Both radar and LiDAR have excellent robustness in the darkness, right? LiDAR system very good, so they have even better performance at night because there is no ambient sunlight, thus might interfere with the detection of the IR. So robustness in the rain and snow falls. One of the biggest benefit radar sensor is their performance under the adverse weather conditions. Okay, like snow, heavy rain, or any other obstruction in the air, such as frost and particles. Okay. So classification objects, that's only camera itself as classifying objects such as vehicle, pedestrians, speed sign, and many other. Receiving to destruct the camera system, the only sensor able to interpret two-dimensional information such as speed sign, landmark, traffic light. Measure speed radar the best can direct measure velocity of object by exploiting the Doppler frequency shift. The system called the radar system have been widely used in the automotive industry in recent years, with the current system being highly compact and affordable. So the radar, the cameras, the same hold for mono cameras, which have the price well below $100. Stereo camera expensive due to increase in hardware cost and a significantly lower number of units in the market. LiDAR again a popular already over the last years, so especially automotive industry. Expensive LiDAR, US $75,000. So package side, both radar and mono camera can be integrated very well into the vehicle. Stereo camera are some punky, with mesh is harder to integrate than behind the windshield, as they sometimes may restrict the driver field of vision. So computational requirement, LiDAR radar require little back-end processing, while camera are the cost-efficient, easily available sensor that require significant process to extract the useful information from image, and which adds to the overall system cost. So here the table can summarize the benefits for each equipment: camera, radar, and LiDAR. You can see the table for reference. So today we all information about that's the summarizing the autonomous vehicle, how the different automaker the market they use different things for design the autonomous vehicle, and what the benefit and what the disadvantage for its sensor. Others collect all the idea and summarize everything for you. In case you need it for writing the paper or something. Okay, next we talk about the camera. In the history of camera, we use the pinhole camera. Everything camera designed by placing the light period with a tiny opening, the pinhole, between the object and its wrist, so the light emitted by the object passes through the pinhole and lands on photosensitive surface which store the light information as image. The reason why the pinhole has been made so small to avoid image blurring due to superimposing rays of light stemming from various parts of the object of interest. Right here, you can look at the picture right here. They go to the pinhole right here. They create the picture of the plane, image plane right here. the model of pinhole camera is something like this. You have this the image plane right here, the pinhole right here, the object right here, the light goes through the pinhole, and they have picture on the image plane, and the distance between the image plane to the pinhole, right, the focal length f. Okay, the center of projection right here, and it's image plane, the focal length f right here. So the formula relates between the p into the space go to image plane p prime right here, the formula right here. Okay, and the problem with the pinhole camera light passing through the pinhole is not sufficient to generate a decent image or on an image sensor. So if one were to increase the amount of light by widening pinhole opening, so the ray of light from the other parts of the object of interest would superimpose each other, they leading to a blurring effect. So the larger pinholes, the brighter image, but at the same time, the more severe the blurring of the object on the image plane would be. Okay, right here you can see the larger the pinhole, the more the light will go right here, and they create the brighter the image, okay, but at the same time more the blurring on the image. To solve this problem, so we're able to capture multiple rays of light that emanate from the same points of the object of interest. So we use the aperture, right? To show this one, you can look at this picture. You can see aperture right here. They can move to block the ray and to control the ray go through the hole. Okay, go through lane. Okay, it's made the image more clear, right? So by reducing the diameter of the aperture, so light rays passing through the lens on the outer edge are blocked, which reduce the size of the COF on the image plane. What is COF? COF means the circle of confusion, COF, right? The points on the object that's closer or farther away, such as P2 right here. Now appear on the focus on the image plane because the set of the light rays emanating from them doesn't converge into the points, so but rather in circle with finite radius instead. The blurry circle is usually referred to as a circumfusion. Okay, to reduce blurring, the apertures can be used with concentric opening of usually adjusted side plate directly behind the lens. The purpose of the aperture is to control the light of the lens, so it reduce the blurring image on the image plane.